Hi everyone. Welcome to another practice problem walkthrough video from feesacademy.com. In short, in this video, we'll work with the conservation of mass and energy in their pressure format. Let's start with reading the problem statement together. A water intake at a reservoir has a radius of 0.486 meters. The water flows in at a speed of 0.405 meters per second. At the generator building, 183 meters below the intake point, the water flows out at a speed of 9.45 meters per second. Part A. What is the radius of the outlet? Part B. What is the difference in pressure between the intake and outlet? We start with making a list of unknown and known variables. On the left-hand side, we have the radius and the velocity of the intake, plus we can assume the height of the intake is the reference, therefore, equals 0. On the right-hand side, we know the outlet's velocity and height. Since the outlet is 183 meters below the height reference, we have a negative sign for it. For part A, we start with the conservation of mass. We know that the rate of the volume of water in the pipe should be equal to the rate at which the water comes out. Taking this, we can work through this by replacing the volume over time with velocity times area. Since the pipe is circular, we can replace the area with the pi times a squared and then work through the equation. Finally, we plug the values in and get about 0.1 meters or 10 centimeters. We start with energy conservation but in its pressure format for part B. Here, on the left-hand side, the first term is the water pressure at the inlet, and the second term is very similar to the kinetic energy but divided by the volume of water. The third term is the gravitational potential energy divided by the water volume. The inlet height is 0 since we took its height as the reference point. By rearranging this equation, we can find the pressure difference between the outlet and intake. Before plugging the values in, let's check the units. On the right-hand side of this equation, we have 1/2 of ρ, water mass density, in kilograms per meter cube. V, the velocities are squared, so they are in meters squared divided by seconds squared. The G times H is in the same unit, so as you see at the end, we get to kilograms per meters per second squared, which is the standard unit of pressure. Now that we can trust our equation, let's plug the values in and find the final pressure difference. It turns out the pressure difference is about 1.7 megapascal. Thank you very much for watching this video. Please check our website feesacademy.com or our YouTube channel for more practice problems. If you found it helpful, please consider subscribing to our channel. This is the best way to support our work.